Hi everyone, hope all are doing good. So in this session, we shall discuss some problems on cantilever beam and how to draw the shear force and bending moment diagram. In the last class, we discussed about the derivation part. Now we'll go with practical exposure. Okay. So now let us take the first example for a cantilever beam. A cantilever beam of length 2 meters carries the point loads as shown in diagram. Draw the shear force and bending moment diagram for a cantilever beam. So if you see the structure, whereas one end is fixed and it is having 3-point loads. At point end of the beam, you are having 800 newtons, and at some point C, 500 newtons, and at point B, it is having 300 newtons. And the total length of the beam is, you can see that 0.5 plus 0.7 plus 0.8, it is 2 meters. So first we shall go with shear force diagram. We know that shear force diagram is nothing but the algebraic sum of all the forces acting on either sections of the beam. So now draw the reference line like this. Okay. Initially, first we shall go with free end. So at free end, it is having 800 newtons. So draw some vertical line and mentioning at 800 newtons. And next at point C, without carrying this 800, it cannot carry this 500. So at point C, there will be, so this 800 plus 500. What will be the value? 1300. Okay. So already we have drawn for 800. Up to this point, it is constant. Let's mark it BF. From this height, how much it is increased? 500. Okay. So from that point to B point, it is fixed. So draw again a horizontal line. How much it is adding after that? 300. So 1300 plus 300, it is 1600. So increase value is 300. So mark like this. After that, it is fixed. After that, it is fixed. It is 1600 newtons. Okay. So this is how we draw the shear force diagram. Next is bending moment diagram. So bending moment diagram is nothing but algebraic sum of all the moments acting on the beam. As I mentioned that at bending moment at a point at the fixed end or free end will be 0. So bending moment at for this particular point is 0. And at C, we are seeing that vertical force is acting of 800 newtons with a distance of 0.8. So 800 into 0.8 is nothing but 640 Newton meter. We will be mentioning as C. When you go with bending moment diagram at B, so this 800 plus 0.8 plus 0.57. So 800 into 1.5 plus this 500 into 0.7. So roughly this will be 1200 plus 350. So what is the value? 1550 Newton meter. Now at point A, 800 into this entire length 2 meters plus 500 into 0.1, 1.2 plus 300 into 0.5. The value will be 2350. And now join these all points with the curve freehand. So this is called your bending moment diagram. So if everyone is understood, so for better, it has taken, as it is acting from the top to down, it will take as negative. I did not mention that, except that I was clear. So I hope everyone understood. Now we'll go with cantilever beam with UDL acting. So cantilever of length 2 meters of uniformly distributed load 1.5 meters or the length of the beam and point load 2 kilonewtons at a distance of 0.5 meters from free end. Draw the shear force and bending moment. For a cantilever beam, he has given an entire beam with UDL of 1.5 and 2 kilonewtons at a distance of 0.5 from right side. So first, what is the first step? We have to find the bending shear force diagram. At this particular point, it is 0. And then at particular B, you will be having how much? 2 kilonewton is wrong. 2 plus something. Why? Because at this particular B, we are having certain UDL. So, considering the section at C to B at free end, the shear force will be W into X. So, 1.5 into total length is 2, 3 meters. So, at B, X of X is 0 and FC is 0.75. So, it will be XC is equal to 2.75 kilonewtons and at FA is equal to 5 kilonewtons. So, here will be, let's see, this is 0.75 plus, and at E point, if it exactly take at the center, 2.75. So, hope everyone clear with SFD. Next, BMD. First point, bending moment diagram will be total length into x by 2. So, minus 1.5 into x into x by 2. So, at bending moment at point B is always 0. At this particular point, 0. And at particular C, this force into perpendicular distance. So that is 0.75 to 0.5 square. That is 0.1875 minus. And at a particular distance x, this is the volume. So I have given one more example to solve for you. Practice it. Thank you.